Let's try another dimensional analysis problem. Here, we want to convert 45 kilometers into feet. So we're doing distance. Now you can use your conversion chart, the one I provided for you, and you'll notice in this conversion table, there is no conversion of kilometers to feet. In the metric system, we've got kilometers to meters. In the metric to English conversion, there's a miles and kilometer relationship, but there's no kilometers to feet. So here's an example where we're going to have to do two things. We're going to have to do two steps or two conversions. And so one of the things you'll recognize is we do have a kilometer to mile relationship, and we also have a mile to foot relationship. And so what we'll do here is we'll do one conversion of kilometers to miles, and then we'll do another conversion from miles to feet. And so drawing a map is what I call it, and it helps me kind of visualize the steps that I'm going to take. So here's kilometers, and we'll convert to miles. And once we get there, we can continue on and convert to feet. Okay, so let's set this up. 45 kilometers is what we'll start with. Times. And we're going to have a ratio in here. And remember, we want kilometers to be converted into miles first, so we'll draw the miles in the numerator. And we want to get rid of the kilometers, so we want that to cancel. So we're going to put the units of kilometers in the denominator. Next, I'm going to set up my units first. I'm going to keep going here. I'm not going to worry about my numbers yet. So you'll notice that once we're in miles, we can convert to units of feet. And then we can cancel the unit of miles. We'll put that in the denominator. Okay, so without doing any calculations yet, notice how my units have been set up. I've got kilometers divided by kilometers, so that cancels. Miles over miles, that cancels. And the unit that's left over is feet. Okay, so now we know our units work. Now let's plug in our values. From our conversion table, we know 1 mile is 1.609 kilometers, and that's from our table. Some tables might round this to 1.61, but we'll go ahead and use what's in our conversion table. And in our feet and mile relationship, there's 5,280 feet for every 1 mile. Okay, so when we plug this into the calculator, we get an answer, 147,669.3599 feet. And so this is the answer the calculator gives us, but this is not the correct answer. Now, when we do dimensional analysis, always remember, we will report the significant figures that we're certain of. And so right here, we're certain to two significant figures. Remember, these are all conversions. These are all definitions, okay? And so we can report two significant figures. So of course here we have way more than two significant figures. So we'll have to start using our significant figure rules and rounding rules. So our first number is 100,000, so that's one significant figure. Our next value is 40,000, and so that's two significant figures. And so to two significant figures, our answer so far is 140,000. Please, common mistake, don't say 14, because the answer is not 14. The answer is 140,000. Okay, our next value, 7, or 7,000, is greater than 5. So that's going to tell us to round this 40,000 up. So to two significant figures, our answer is 150,000 feet. We can also report this in scientific notation if we have to. Now be careful here, watch this. For scientific notation, if there's no decimal place, you can imagine there's a decimal place here at the end. And we're going to move it to the left 1, 2, 3, 4, 5 times. Remember, in scientific notation, we want one number in front of the decimal place. Okay, so you see the problem here. Our original answer had two significant figures. When we converted to scientific notation, you notice that we have 1.5, that's two significant figures, but now we have 4 other zeros, trailing zeros, with a decimal. And so remember, for scientific notation, we read these values for our significant figures. So here, we've converted to 6 significant figures, and that's incorrect. And so how do we get back to 2 significant figures? Well, we'll just go ahead and drop those zeros, and this will just be 1.5 times 10 raised to the 5 feet. So here are our two answers. These two answers are the same. They're equivalent. They both represent the same number to two significant figures. One is in our standard notation, the other is in scientific notation.